Hello and welcome back. So in this video we would look at another activity that would help us determine the nature of roots of any given quadratic equation. So without wasting much time, let's get started. So basically I will still use my create function, the create script to create a file called roots or quadratic roots. So underscore roots, or it should just be nature of roots, but then this should be fine. So it should create this file for me and then make it executable. Okay, so now I want to access this file. Don't worry, all these files will be, I will share a link in the description where you can get access to all these files. So, okay, so basically to determine the nature of roots, we make use of something that we call the discriminant, right? If you look at the general equation, or the quadratic equation, what people call the almighty formula, where I come from, we have the discriminant, which is basically b squared minus 4ac, right? And then that is if you have ax squared plus bx plus c, right, to be your quadratic equation equals 0 to be a quadratic equation, then this becomes the discriminant, right? Discriminant. Right. So now you use this to determine the nature of roots. So how this works is that if you have b squared, right, or if you have your d, so let me make this d equals that. If you have your d to be less than 0, right, which means that this whole thing is going to be negative. And when it's negative, the square root of a negative number becomes a complex number. So we say you have complex roots, right? Or you would have complex roots. If your d is greater than 0, then we said you would have real unique roots. Unique roots. And then if your discriminant is equal to 0, if your d is equal to 0, then we say that what you would have real repeated roots. Okay. So basically this is the math, or this is the logic we are going to follow. So which means that we are going to declare a function. That declaring a function or defining a function, the function is supposed to return a value, and then we do some checks. So which means that we would be making use of the if statements we learned in some videos ago. If you are not used to it, you can go pause here, go watch and refresh your memory on if statements or conditionals, and then come back here and continue. So basically to do this, I define my function. So I call it roots or nature of roots. Okay, let me just the nature of roots or roots nature. And then this would take some arguments. Obviously, in bash script, we don't pass the argument there. Okay. And then this nature of roots, expect that the first argument you give it should be the sorry. I expect that the first argument you give it should be the value for a. So I would declare a variable called a and then assign it to the first argument, and then declare a variable called b and assign it to the second argument that will be passed when you call the discriminant or the root nature function, and then hope that you would pass a third variable. Then I catch it and call call it C. So this, I will have to call this on the third, then call this on the second. Okay. So now we've declared our variables. You can actually make them local by just saying local here, so they don't get used outside of this function, right? So local. Okay. So now we have okay. So now we have local variables defined or declared, right? So the next thing I do is to compute what the discriminant, right? So here, as I said, you can compute the discriminant. There are several ways you can do this. You can choose to use the BC or the awk. So I would use the BC here. I would encourage you to try to see how well you can use the awk to do the same thing. So I can echo my b squared, right? B squared minus 4 star A star C, right? So basically I can echo this here and then pipe the answer towards BC dash L. Okay. So now that I have this, right, this basically would just output the answer for me, but then I want to be able to catch it or store it in a variable that I can use to do my conditionals. So I can just call the discriminant or name it discriminant. And then we say if you want to assign this, then you have to pass the dollar and this. So now when I save this, I expect that this should be executed all right, but then it should be returned and stored in a variable called discriminant, right? And we can actually make this onto local. Okay. So now that we have these local variables, then I can now go ahead and check my condition. So declaring variables. Variables. It's a good thing to always comment your codes, as they would help you to remember later what you actually did. Calculating our discriminants. And then now we want to check the roots or determine the roots. The roots or the nature of roots. Okay. So to do that, we said we'll use conditionals or if statements, right? So from the previous video, we said to do the if statement, you do if, and then a certain condition is true, you put them in the either double quotes, a double square bracket or single square bracket that is really spaced. Then you do something. Then after doing that, if you have other condition, do else, elif, and then you do it. If everything is true, or if you are done, then you end with a phi or fi. Okay. So basically that is that. So here the condition we check is that we want to check whether the discriminant is less than 0, right? So if the discriminant is less than 0, right? So if the discriminant is less than 0, it should then do something. Then do what? It should echo, you have what? Complex roots. Complex roots. Or your equation or your equation has complex roots. But then else if, so here we say, sorry, elif, the discriminant. Bear in mind that the reason why I can use this less than sign as it is right, is because I use the double parenthesis, right? And this double parenthesis is known as a compound expression. It enables us to use the mathematical symbols inside the conditionals. So you can either use this or you'd use your square brackets and then use a minus GT, right? As we used in the previous video. I am just using this notation so that you would know that there are different ways of doing it. So we use the compound expression to do this so we can actually use the math symbols. Okay, so if the discriminant is greater than 0, then we have what? Then echo your equation has real roots, real unique roots. Okay. Then the next possibility, if it is not less than and is not greater than, then it has to be equal to. So here we don't bring another else if, we just end with an else. Else what? Echo your equation has real repeated roots. That's all. So hopefully this should work. Then we are not done. We have to tell it that we are done with the if statement by just bringing the if upside down. So fine. So this is it. So the logic here would check the discriminants that we've calculated here and then use it to determine what to echo for us, right? So once you are done, you save it and then you come down here and call your function. We call it nature or root nature. So root nature, and then we want to pass it an argument. So you can try it with a function, let's say 2x squared plus 2 plus 2, plus 2x plus 2. So that will be 2, 2, 2. Let's see the nature of roots this will give us. So this is for the function 2x squared plus 2x plus 2. If I save this and I run it, hopefully I should, 2./quadratic roots. It tells me that your equation has real repeated roots. Interesting. I would never have known on top of my mind if not for this equation or this code. So what if I try it for a different one? Let's say -2 and then -2 here. What then happens? Okay, and then let's change this one to 3 and then -2 here. Let's check the nature. They are all real repeated roots. I see. So let me make this one 1 here and let's see what happens. All are real repeated roots. Okay, what about 1, -7, 1, -7, 10? Hopefully this should give me something else. Let me clear and rerun my code. Since it has real repeated roots, there's something wrong with the logic. So let's go and check what the problem is. Okay, so apparently there's a problem wrong with our logic. So let's go through the code and detect where the problem is. Okay, here. So here, instead of calling the variables, we place the alphabets there themselves. So they are not actually doing what they're supposed to do. So the values are not being replaced. It's just the variables that are actually being used, which is wrong. So you can also actually even put this into parentheses to make it look different. Now, hopefully, if I should run it, it should work. This one would still check for the value though, but then you can still put the dollar there if you want to, right? So if I save it and run it, hopefully I'm expecting to get that one has complex root. Okay, actually two has complex roots and then one has a unique root. So yeah, now you can decide to build upon this project by making this function compute and then go ahead and compute the solution of the given equation. The ideal goal or way to go is just to give the equation or the almighty formula or the quadratic equation or the quadratic formula to it and then have it computed. Okay. So that'll be all for this video. If you've enjoyed this video, don't forget to like and subscribe. And we can't wait to see you in the next one. Thank you.